this video, we're going to introduce quadratic functions, different characteristics quadratic functions have. And what we're going to do is we're going to relate it to linear equations. We're going to look at these equations first and look at some characteristics of these equations. We've gone over linear equations. Linear equations have a formula that looks like this right here. And in this formula, there's certain characteristics. The slope goes right here. The Y-intercept goes right here. Once you know those characteristics, then you can look at an equation and tell what the slope is. You can tell what the Y-intercept is. Those characteristics help you graph it. Quadratic equations also have a formula. Here's what the formula for a quadratic equation looks like. Remember, a linear equation has an exponent of 1 that we can't see right there. Quadratic equations are always going to have an exponent of 2. Numbers go in these spots right here, and they change what the quadratic looks like once you graph it. Here's an example of a quadratic equation. So just like a linear equation, we're going to start talking about the characteristics of this quadratic equation to help you graph it. First thing that we need to discuss is, what does the graphs look like? Well, what does a linear equation look like when you graph it? This is going to be a line. It can have a positive slope, it can have a negative slope, it can have a slope of 0, it can have a slope that's undefined. Quadratic graphs look like this. They create U's and C's. They create graphs that look like this right here. Now, since this section is quadratic functions, we're only going to worry about the graphs that create functions. This one is a function. Remember, we've got a vertical line test, and a lot of what we're going to go over, you're going to have to remember old concepts, like the vertical line test. The vertical line test is a line that you draw vertically, and if it only touches the graph in one spot, then it is a function. That means this one right here would be a function. This one right here would be a function. This one right here would be a function. This one would not be a function. This one right here would be a function. These arrows that are pointing in this direction, they keep going at a slight angle, and they would keep going in that direction, but there's no way I can draw a line going straight up and down that's going to touch this graph more than once. That means this one right here would be a function. This one and this one, which are also quadratic graphs, would not be functions. So of the graphs that we're going to look at, we're only going to look at these two types, the ones that are functions. So again, we're going to go over important parts of a quadratic graph. One thing that you need to remember, sort of like remembering what the slope is on a linear equation or a linear graph, you need to know what the vertex is. The vertex is going to be a point. That means it's going to have an x and y coordinate, and it's where the graph begins to change. That means if the graph looks like this, it's going to have a maximum that is a vertex. If the graph looks like this, it's going to have a minimum that is a vertex. And what they're going to want is either they're going to want the value, meaning one number, or they're going to want the point. And the vertex is always a point right here. If they're talking maximum and minimum, sometimes they only need one value. But if they're talking about the vertex, they want this specific point. They want the coordinates for that point. So the first important part of a quadratic graph is the vertex. Next important part is the axis of symmetry. Now, the axis of symmetry is always going to be the equation of a line. And since the line is going to cut the graph into two equal parts, that means if I draw a line going straight up and down on each one of these, it's going to cut it into two equal parts. That means the equation of this line is always going to start off with x is equal to. Remember, an equation of a line that goes straight up and down and does not touch the y-axis will only have the value of x in it. So they're going to ask for what that equation is of that line that cuts these graphs into two equal parts. The next part is going to be really easy. It's going to be the x and y intercepts. It's going to be where that graph runs into or intersects the x-axis, and it can be a point or it can be a value, and where the graph runs into the y-axis. our first example. Our first example, we're going to look at this graph right here, and we're going to find each one of these. We're going to find the vertex, the axis of symmetry, the y-intercept, the x-intercept, and whether or not it has a maximum and minimum, and what is that maximum and minimum. The vertex is the point where this graph begins to change, and that would be right here. This is the vertex. What I need are the coordinates for that. So to find the coordinates of this vertex, remember a point has parentheses. The x value is first. I start right here and I go back 1, 2. That means the x coordinate for my vertex is -2. And then I need to go up 1, 2, 3, 4. The y coordinate for my vertex is 4. So when they ask for the vertex, they're looking for this point right here where the graph changes. It can be a maximum or it can be a minimum. Next, the axis of symmetry. Remember, our note said that the axis of symmetry is always a line. It's a line that's going to cut this graph into 2 equal parts. A line that goes straight up and down will always have x is equal to. And then I need to look where it goes through or runs into the x-axis, and that would be at -2. So my equation of my axis of symmetry, which would look like this right here, because it's going to cut this graph into 2 equal parts. This part and this part are mirror images of each other. That's the equation for the axis of symmetry. Y-intercept. Where does this graph run into the y-axis? It runs into the y-axis at 0. If they wanted the point, it would be 0, 0. What's the x-intercept? Well, I have 2 x-intercepts. I have this graph running into the x-axis right here, and I have this graph running into the x-axis right here. So the x-intercept, you could put -5 and 0. If they wanted coordinates for these points, you could also put down coordinates for these points. Does this graph have a maximum or minimum? Well, it looks like it will go on forever going down, but it's got a maximum because it's got a point that it can't get any higher. So it would have a maximum. What is the maximum? What's the highest? And since we're talking about going in this direction, what's the highest value of y it can have? The highest value of y it can have is 4. These are the type of questions that they'll ask. They'll ask, what is the vertex? What is the axis of symmetry? They may ask what the y-intercept is. They may ask what the x-intercept is. They may ask if it has a maximum or minimum, and what is that maximum or minimum. Next example, we're going to find the vertex first. So I'll look at my graph. This is the point right here where this graph begins to change. I need the coordinates for that point right there. My first coordinate is my x value, so how many do I go over? It looks like I go over 1, 2. And then I need to go down. 1, 2, 3, 4, 5, 6, 7, 8. And since I'm going down, that's -8. What's the axis of symmetry? What's the equation of this line right here that cuts this graph into 2 equal parts? Well, it looks like it's always going to start off with x is equal to. X is equal to 2. That's the equation of that line. What's the y-intercept for this? Where does this graph run into the y-axis? Looks like it runs into the y-axis right here at this point right here. 1, 2, 3, 4. That would be -4. What's the x-intercept? Where does this graph run into the x-axis? Right here and right here. The x-intercepts, -1 and 5. Does this have a maximum or minimum? This has a minimum. What's the minimum value you can have? How far down can you go on this? You can go down to -8.